tin, brass, gold, or silver. Traditional tea sets, for instance, are often made of silver-plated copper or zinc. The plating process is called electroplating because the key to it all is electricity. They start by tying strands of copper wire to a copper support frame, copper being the best metal for conducting electricity. Then they attach the steel parts they'll be plating. When they hook up this support to an electric current, electricity will run from the support through these wires right to the pieces. They do the electroplating in a tank. After filling it with water, they add a handful of chemicals to help conduct electricity, because water alone won't conduct it sufficiently. Along the sides of the tank, in bags, are metal baskets. They contain bars or balls of the plating metal, in this case cadmium. Workers connect the support frame with the steel parts to the negative terminal of an electric source, the baskets of cadmium to the positive terminal. Then they switch on a steady DC current, no stronger than 6 volts. The electricity dissolves the cadmium, lacing the particles with a positive charge. They travel through the water and attach themselves to the negative charged steel parts, creating a smooth and even layer of cadmium. Thin plating requires just a few minutes in the tank, thick plating several hours. Then workers rinse the parts in water for about a minute to remove the chemical residues. To make the parts even more rust resistant, workers immerse them in a series of compounds. This triggers a chemical reaction in the plating, enhancing its ability to withstand corrosion. This reaction, however, changes the color. A final rinse in hot water, and this cadmium-plated steel aerospace part is finally ready. From start to finish, the process has taken about 90 minutes. To plate with chrome or gold, they have to use a chemical compound containing gold or chromium. That's because electricity can't dissolve solid chromium well enough, and it can't dissolve solid gold at all. The compound dissolves in the bath like salt, but then solidifies once it reaches the object being plated. Metal plating is very durable, but if subjected to a lot of wear and tear, the object will eventually have to be replated. Have you ever wondered why men's buttons are traditionally on the right side of a garment and women's on the left? Legend has it that this enabled a man to unbutton his coat with his left hand while drawing a sword with his right. Wealthy women, meanwhile, had their buttons sewn on the left side to make it easier for their right-handed maids to dress them. One way to make plastic buttons uses a multi-layer sheet of synthetic resin, hence the industry term sheet buttons. Workers start by mixing liquid polyester resin with a catalyst to gel it. They pour the material into a revolving drum, which disperses it evenly. They spray a solution containing an ultraviolet pigment on this first layer only. You'll see why later on. For this particular model, they make grooves in the resin while it's still malleable. This will create a design. After about 5 minutes, the resin gels, and they can mix and add a second layer in a different color. Besides building up the thickness of the sheet, the resin flows into the first layer's grooves, creating a design of contrasting lines. Once this second layer gels, they mix and pour in a third color. The drum spins for another 10 to 15 minutes until all the layers cure. A resin sheet can be comprised of up to 4 different color layers. Workers can now remove the sheet. It's hardened enough to be cut into buttons. but it's still flexible enough not to crack when cut. Now they feed each sheet into a press that's outfitted with a die for that particular button model. The press punches out circles in the diameter of the button. These circles are called blanks. You can see the different color layers. The blanks move on to the machining center, where they'll be transformed into buttons. Automated equipment loads them onto carousels, the back of the blank facing outward. How does the loader know which side is which? Well, remember that ultraviolet solution the worker sprayed onto just the first layer of resin? A UV detector scans each blank to make sure that first layer is facing upward. If it isn't, the machine rejects the blank, then flips and reloads it. The carousels first run the back of the blank against a series of cutting heads. The heads are changed according to the model being produced. For this one, the heads gradually carve a curved back. The equipment then transfers the blank onto a second carousel, exposing the front side this time. Again, a series of cutting heads gradually carve the front of the button. The shape of this model exposes the different color layers underneath, creating a veined effect. The last cutting head drills the holes. Here you can see the full progression from blank to button. Now they polish the buttons for several hours in drums containing abrasive ceramic stones and pumice. Then workers flush the drums with water. The